Hello, and we're back for Chapter 2 Approaches to Problem Solving. Alright, let's get the pen ready to write because I can't talk without writing. In Unit 2A, we are going to understand, solve, and explain, and you will be not surprised at all that we're going to call this use. Alright, understand, solve, and explain. Three-step problem solving, USE. Understand the problem, step 1. Think about what the problem asks you to do. Draw a picture or diagram to help make sense of the problem. Now, this is not always necessary. Suppose you're doing a thing where a pair of jeans, it's like $30 per pair. These are the big baggy ones from the 90s. And we've got to have like a zipper. We got some pockets. Drawing this is not going to help you solve the problem at all, right? It stalls a little bit, but drawing a picture or diagram doesn't always help. Sometimes it does. Ask yourself what the solution should look like and try to map a path, either in your mind, at least have a clear idea of where you're going, or write it down. I found a lot of students that write down in words what their steps are have an easier time of solving problems later on. It helps you lead you from your understanding of the problem to its solution. One student in particular stands out, and just everything was written as a note to self to step through their work. It was probably 4 years ago. But it stands out, right? It's always a good idea. And always revisit your understanding of the problem. This problem is never going to change. You could always go back and read it. Make sure you're solving the right thing. Make sure you're doing the right thing. All right, so how do we solve this problem? Obtain any needed information or data. For multi-step problems, be sure to keep an organized, neatly written record of your work. So maybe some math, and then the words telling you what to do, and then some math, and then I added 3. That might be helpful to some of you. We could double check each step as you work to avoid carrying errors through to the end of your solution. Negatives and denominators are the bane of any young mathematician's adventures, your existence. So always look for negatives. Make sure your fractions are still there. Constantly reevaluate your plan as you work. Oh, I thought I was going here. It turns out it's leading me down a different path. And we always want to explain our results. I make my students in college algebra do this. You get an answer, fine. What's that 5 mean? What does it mean in terms of the real world, in terms of the question asked? Be sure that your result makes sense. Recheck your calculations once more, or even better, find an independent way to check your result. Identify and understand any potential sources of uncertainty in your result. If you made assumptions, were they reasonable? And write your solution clearly and concisely using complete sentences to make sure the context and meaning are clear. All right. As we're solving problems mathematically, the units of a quantity describe what that quantity measures or counts. Is it dollars? Then it's money. Is it miles? It's a distance. Is it inches? It's a length. We don't really think of inches as a distance, but it could be. How many inches is it from Las Cruces to El Paso? I don't want to figure that out, but we could because it's like 42 miles. Now, unit analysis is the process of working with units to help solve problems. So we'll always have an eye on our units and use unit analysis to help us set the problems up so we know if we should multiply or divide or what operation should be handled. You're buying 30 acres of farmland at $12,000 per acre. What is the total cost? Well, first of all, you're probably not in southern New Mexico because most of that land is $100,000 per acre. So I'm buying. Where are we at? First of all, understand the question asks about total cost. Right? Total cost. The question is the most important thing we're going to do. This is our action. This is our goal. Our action goal. What is the total cost? When I get a number, when I get an answer, I'm really hoping that it's a dollar amount because dollars are the only thing listed. I want cost. All right. So we know that the price is given in dollars per acre. $12,000 per right, divided by 1 acre, $12,000 for 1 acre. So we write the division of acres in fraction form. That allows acres to cancel out. All right, we might cancel out acres. And now dollars is the only unit left. 30 times 12,000 is $360,000. So we understood what we were looking for. We solved it using unit analysis. And to explain, we answered the question in a complete sentence. We have found that purchasing 30 acres of farmland at a price of $12,000 per acre will cost a total of $360,000. Some of you can do the math just like the snap of fingers, right? Some of you, unit analysis will help you get a little more comfortable with the math. Keep in mind you cannot add or subtract numbers with different units, but you can combine different units through multiplication, division, or raising to powers. We can't add inches and miles unless we say 42 miles and 3 inches, right? But we can't combine the 42 and 3 in any way. But we could multiply. It's easier to keep track of units if you replace division with multiplication by the reciprocal. This, very important. Division is the same as multiplying by the reciprocal. So instead of dividing by 60 seconds per minute, I can multiply by 1 minute over 60 seconds. So we're going to come back to this. There's a graphic on here. 60 seconds per minute or 1 minute per 60 seconds. I mean, they're not the same thing. So I'll put an arrow. But they represent the same relation between seconds and minutes. We're only relating seconds and minutes. Do we need minutes in the numerator or do we need seconds in the numerator? And our math will help us discover that. When you complete your calculations, make sure that your answer has the units you expected. If it doesn't, you've done something wrong. All right. So this is not an always thing. But in general, there are some keywords that will lead us forward in math. The word per is always division. Miles per hour is miles divided by hours. If you see the word of or a hyphen, that's telling you it's multiplication. You might find on your utility bill kilowatt hours. That's kilowatts times hours. All right, so per if it's a division, usually a hyphen or of if it's multiplication. Square is raising to a second power. And it's literally also, if I want 2 square feet, I don't know why I wanted to do that. 4 square feet. Pretend that's a 4. Fancy 4. It means it's 2 squares that are each a foot long in one direction and 2 squares in the other direction. Notice this makes a square. That's why it's called square feet. It will always make a square of some sort. Cubes, cubic feet. Also, what do we have? We have length, width, and height. So cubic feet literally will always make us a nice little cube. It has 3 dimensions. All right. So how many crates do you need to hold 2,000 apples if each crate holds 40 apples? The question asks how many crates, right? How many crates do you need? That's where we start. I want my answer to be number of crates. Now, each crate holds 40 apples. That doesn't necessarily say it's 40 apples per crate, but just like in our critical thinking chapter, sometimes we have to reword it in an equivalent form in order to get how we can use it. 40 apples per crate. Each crate holds 40 apples. That means 40 apples per crate. So we could write that literally as 40 apples per crate. Now, 2,000 apples divided by 40 apples per crate. But notice how apples, they're both, here we're going to end up with apples squared per crate, and that doesn't seem like a good answer at all. So what we're going to do is we're going to change this division to multiplication. I tried to change it on the slide itself, but Pearson had an error. It happens. Typos happen in books. Typos happen online. Typos happen in these. And I couldn't find a successful way of editing that, so I wanted to point it out in the video. Division turns into multiplication of the reciprocal. So 40 apples in one crate is one crate holds 40 apples. Now an apple, just as a unit, cancels the apple in the denominator. This is always assumed to be over 1. So we have 2,000 divided by 40 is 50. Apples cancel out. Crates. We'll have 50 crates to hold 2,000 apples at 40 apples per crate. All right, so conversion factor is a statement of equality that is used to convert between units. And this is what I mentioned earlier with the 60 seconds per minute. 12 inches is 1 foot. That's absolutely true. I could divide both sides by 1 foot. And on the right, I'll have a 1. On the left, I'll have 12 inches divided by 1 foot. If instead I wanted to divide both sides by 12 inches, well then 12 inches divided by 12 inches is 1. And here I have 1 foot over 12 inches. So with this equality, you could write it as a fraction. You could write the equality as a fraction equal to 1 in many different ways. And we'll write it in whichever way it works best for us. This is true for 60 minutes equals 1 hour. So I could have 60 minutes per hour, or I could have 1 hour per 60 minutes. These are both equal to 1. They're the same thing represented, just how do we need to use it? All right, so we want to convert a distance of 9 feet into inches. We don't want to do 42 miles, that's too much. So 9 feet into inches. I know that 9 feet is just 9 feet. I want it to convert into inches. So I know there are 12 inches in 1 foot. Since foot is in the numerator here, anytime a fraction is not written, there's assumed to be a denominator of 1. Since feet is in the numerator here, I want to make sure feet is in the denominator for my unit cancellation. So I'll choose the 12 inches divided by 1 foot. 9 times 12 is 108 inches. Our feet canceled out. All right. How many seconds are in 94 days? 94 days, what's that? A little over 3 months? Let's check it out. 94 days to get to seconds. So I'm going to write a plan. Days to hours to minutes to seconds, right? That's my plan. Okay, so I have 94 days. I need to cancel out days. My days and hours are related. Since days is in the numerator here, I want days in the denominator for my conversion. 24 hours in 1 day. All right. Days to hours. Now, hours and minutes. Notice that the hour is in the numerator here. So hour should be in the denominator in our second written fraction, right? Minutes and hours are related, so we got that. So here we cancel days to days, hours to hours, and minutes, 60 minutes cancels the 1 minute that's in the 60 seconds. So our days cancel, our hours cancel, our minutes cancel, and it looks like we're going to multiply these all the way across. 94 times 24 times 60 times 60 is 8,121,600 seconds in 94 days. Fantastic. All right, but what if we're raised to powers? Well, 1 yard is 3 feet. Here's 1 foot, 2 feet, 3 feet. 1 yard again is 1 foot, 2 feet, 3 feet. So when I have 1 square yard, I make a yard with I make a square, length 1 yard on every side. It turns out that that will be 1, 2, 3, 4, 5, 6, 7, 8, 9 square feet, right? There's 9 little squares inside of it. Let's suppose you want to carpet a room that measures 12 feet by 15 feet, making an area of 180 square feet. But carpet's usually sold by the square yard, like fabric. How many square yards of carpet do you need? Well, we'll start with 180 square feet is how much I need. I know there's 1 square yard per 9 square feet. I chose this rendering because I want my feet squared to cancel out. I'll end up with 180 divided by 9. The only unit left is square yards, and 180 divided by 9 is 20 square yards. And that was horrible. We should buy 20 square yards of carpet. Explain. We should always finish it off with a sentence to make sure it's reasonable for the problem, and that does seem fairly reasonable. The price is probably going to be unreasonable, but it is what it is. How many cubic yards of soil are needed to fill a planter that is 20 feet long by 3 feet wide and 4 feet across? Ooh, bad planter. There we go. We got 20 feet, 4 feet tall, 3 feet deep. I want to fill this all with soil. So maybe pictures do help sometimes. Of course, I wrote that right over the top. The volume, right? What is a volume? A volume is length times width times height. We find the volume is 240 cubic feet. I want to know how many cubic yards of soil it takes to fill them. So let's go ahead and erase this. Oh, look at that. That's easier. The volume is 240 cubic feet. 1 yard is 3 feet. So 1 yard cubed is 3 feet cubed, right? 1 yard is the same as 3 feet. 3 to the third power, what we're not showing you here, is 3 to the third feet cubed. 3 times 3 is 9. 9 times 3 is 27. All right, so a little step here. Remember, exponents do go across multiplication, distribute through multiplication. So 3 cubed, feet cubed. Now we could do our division. 240 cubic feet times, notice how the feet cubed cancel out. Or in cubic yard, I'll have 240 divided by 27, 8.9 yards cubed. Now, think about the reasonableness. Is this reasonable? Feet are smaller than yards, so we should have more feet than yards for the same amount. So it makes sense that the number for yards is less than cubic yards. The number for cubic yards is less than the number for cubic feet because cubic feet are smaller measurements than yards, so we would need less of them for the same area. All right, so it seems reasonable. Converting between currencies is a unit conversion problem in which the confusion, that's totally true. Conversion factors are known as the exchange rates. These change randomly. I'll call it daily. It's not actually random. It's based on really difficult math formulas and economics of various places. But one we're going to pay attention to here right now, coming up in a future problem, our Canadian dollar is 1.05 US dollars per Canadian dollar, or 0.9950 Canadian dollars per US dollar. They're pretty close to each other. You can see the Japanese yen, and the peso is faring way better than the yen right now, but the Canadian dollar is what we have that's nearly equal. A gas station in Canada, a gas station in Canada. I grew up in North Idaho, and I've been calling it Canada for a long time just because it makes me giggle. But I do know the name of the country, and I can be respectful and call it Canada. They sell gasoline for CAD 134 per liter. Now, CAD, that's abbreviation for Canadian dollars. I want to know what is the price in dollars per gallon. And when we mention dollars, we're talking US dollars. US dollars is assumed unless it tells you otherwise. Use the currency exchange rate in table 2.14. So 1 US dollar is 1.005 Canadian dollars. That's why I pointed it out. Okay, now we're going to need to use a chain of conversions, right? We're looking at gallons and they're looking at liters. They're looking at Canadian dollars, we're looking at US dollars. So there's two things going on here. We use a chain of conversions to convert from Canadian dollars to US dollars and then from liters to gallon. We know the currency conversion for Canadian dollars, and an earlier table showed there are 3.785 liters per gallon. I think I either skipped that or you can find that in the book. That's an excellent resource to have. Look at the tables there. They'll have the conversions for you so you don't have to look them up on your phone. All right, have that table available and open. Here we go. 1.34 Canadian dollars per liter. That's one. Ooh, yeah, I had that written wrong on the last slide. That should be the other way. 1 Canadian dollars is 1.00. US money is worth more. Here we go. This is written correctly. 1.005. So $1.50 is equal to 1 Canadian dollar. Canadian dollars in the numerator for our given problem. So it has to be in the denominator for our conversion. Liters in the denominator of our original problem. So liters need to be in the numerator of our conversion. And so we're looking at Canadian dollars canceling. We're looking at liters canceling. All we have left is US dollars per gallon. So that's $5.10 per gallon. So, excuse me, that snuck up on me. As you're reading about gas prices in other countries, you might read, oh, it's $1.34 per liter. That's crazy, man. I wish our prices were that low. Convert it. I am so glad our prices are not that high, right? Per gallon versus per liter. Oh, they did this cancellations. I just didn't give it enough time. I should have known better. You know, I go through these before I read them to you, talk about them to you, and I still, forget. It happens. Let me know if you have any questions on the homework. I'll talk to you soon.